Okay. Well, hello, everybody, whether it's morning or very late night for some people, perhaps. But welcome to the this MANRS community meeting. This is meeting number 7. And we're going to do this over 2 sessions today. So this is the first session, and we'll have a second session, which will be pretty much a repeat of this one, but that will be at 1500 UTC later today. But what I want to do is just firstly hand over to one of the MANRS co-chairs, Warwick Mitchell, who working for AARNet, the Australian Research and Education Network, and he'll be running you through the program for this meeting. So over to you, Warwick.
Thank you very much, Kevin. First of all, welcome everybody. And as you would have seen on the Zoom notification, we are recording this session. So please make sure that you're aware of that. We're going to go straight into it, and we're going to start talking about the steering committee. Kevin, if you could move along to that slide. As per some notifications that have gone out to the mailing list, the MANRS Advisory Group is transitioning to become the MANRS Steering Committee in November 2021. Of that group, there will be elections for 7 positions on the 1st to the 3rd of November. The nominations are open currently and will close on the 28th of October 2021. Anyone is eligible to serve on the steering committee. Prospective candidates from MANRS participants may nominate themselves. Candidates from companies or organisations who are not actually MANRS participants are welcome to apply, but must be nominated by a MANRS participant. The nomination form is at the website on the bottom of this page, and we will be sending out voting information shortly. So we look forward to your participation in that. We have also launched a new MANRS Initiative, a vendors program, on the 16th of September, which is including Arista, Cisco, Juniper Networks, Huawei, and Nokia. They are doing a number of different actions. Actions 1 is to provide solutions for our common criteria, which is filtering, anti-spoofing, filtering at an IXP level, and protecting layer 2 at an IXP level. They also have another action set, which is to promote the MANRS Initiative. So that's training, that's producing lab materials, technical resources, and hands-on activities relating to that. Ongoing, they'll be helping with the advisory, development, contribution, and promotion of MANRS globally across the internet. So we welcome them on board. The other thing that has really happened in the last year is you can see we've had a significant growth in the number of members. We're now at 600 individual ISPs, 757 ASNs, 95 IXs, 18 CDNs and cloud providers, and with the new vendor program, 5 additional vendors, which is fantastic uptake considering where we started with in 2014. And you can definitely see that we've ramped up significantly in the last couple of years, which is fantastic to see. And now we're going to hand over to Geoff Huston, who's going to be talking to us about measuring the usage of route origin validation. Over to you, Geoff. And if we could keep the questions for the panel session after Geoff, that would be fantastic.
Okay, thanks a lot for that introduction, Warwick. So what I want to do is share the screen, but you know, it's a permissions thing with Zoom. And so I can't share mine myself. Thanks, Warwick. So while someone else is sharing theirs, so let's do this. If this isn't up in all its bright detail, someone shout at me. Otherwise, I am just going to press on. I have only a short amount of time, so I am going to move relatively quickly, other than this title. Isn't it a ripper? So many words. What it really is about is actually measuring RPKI. But, you know, if I really wanted to be accurate, I'm actually measuring, ultimately, route origin validation filtering. So that's what this presentation will be about, trying to sort of measure how well we're doing, how well it's deploying, what are its outcomes. But, you know, let's just go back a little bit and ask one of the really basic questions. We'll talk about routing security a lot, but what are we talking about? What does it mean? What's the objective? Well, here's my here's my list. And, you know, in some ways, it would be really good if no matter what you typed into a router, the router said, nah, that's a mistake. And so all forms of mishaps, even the dreaded Facebook locking themselves out of their own system because of a routing mishap, it would be good if the routing system was smart enough to know, don't do that. That's a bad thing. Maybe we can't protect them from all, maybe some. Maybe it's all about hostile attacks, maybe some. Maybe it's about bogus addresses or ASs. You know, and obviously I think you'd like some of all of these, but what's realistic? And that's a very different question, because in some ways, BGP isn't actually a deterministic protocol. And the outcomes that BGP provides aren't necessarily predictable in sort of the full spectrum of the way BGP actually converges in a routing state. So in some ways, full routing security is impossible. And even then, correlating routing to forwarding is yet another leap of faith, because realistically, inside all of this, what we're really trying to do is not to go down bad paths. And so maybe we're taking the wrong view if we're just looking at the protocol and the policy. Maybe we should be thinking about users. And the intent of all of these mechanisms is not to mislead the user. Maybe the entire objective is just that last one. Don't let users go to the bad place, to being directed along bogus routing paths to bogus destinations. Because if that can happen, all bad things result from there. And, you know, fake certificates, fake websites, misleading users, off we go down a path of evilness. And so what we're trying to do is actually understand the extent to which all of this work we're doing is protecting users. And I think I can sum it up in that one single question. How many users out there, and currently the internet has about 3.8 billion of them, when the destination is bad, how many users can still get there? How many users are capable of being misled by a routing attack? And that's the metric which we'd really like to go down to: nobody. Because if nobody can be misled, I think that's the metric of success here. So the question is, how far are we along that path? Now, in trying to understand that, while it's simple, I suppose, in some ways to measure that outcome, I think you actually need to have a look at the elements of this technology and measure the bits and pieces and our progress along that path. Now, at the moment, we only have one common mechanism in routing security, and this is this concept of route origination attestation. A prefix holder grants a signed authority to an autonomous system, a network, to originate a prefix into the routing system. And that signature is a digital signature. And so a route can be tested to see if its origin AS is encompassed by a ROA. And those that fail that test in various forms are routes that you should be deeply suspicious of, routes that are invalid according to route origination validation. And so what we're looking for is the amount of folk who A, generate ROAs, production, and B, the folk who use ROAs in filtering. So there's production and consumption, and we'd like to measure both. So let's look at the populating side. Don't forget, in the V4 network, there are getting very close to 1 million entries in the V4 routed network. Woohoo! And in V6, we're up in the hundreds of thousands. I think it's around 200,000 from memory. Haven't looked for a couple of days. So out of all those routes, how many ROAs are there? How many attestations are there around protecting it? Now, it's not 1 million. It's not even 500,000. It's 284,000. This is a time series starting from 2 years ago-ish. And that's a pretty dramatic rise. In terms of the scale of internet growth, it's gone from, well, you know, a starting point of, I would actually say, about 75,000 back in April 9, 2019. We're up to 284,000 today. And that it is amazing. It's a constant growth pattern across this entire COVID blighted period. The rower production has been consistent, steady, and constantly growing, which is, to my mind, an amazing effort. So we're doing well on that score. Let's have a look at the IPv4 routing system. And of those million routes, how many routes are covered by a rower? And we're getting close to 300,000. We're getting close to around 30% of the routing objects have an associated rower. Again, this is since two years ago, March 2019. And so in some ways, again, slow, steady, constant growth. All those drops are my fault, obviously. And this fine level detail within a day, not sure. Certain amount of noise in the system to some extent, noise in the routing system and noise in the RPKI system in trying to collect all those certificates and validate them. The other way of looking at it is not by routing objects, but by the V4 address span. So we currently route, I think it's 2.8 billion addresses in V4. Of the routed address span, how much of that span is covered by a rower? And right now, a little bit over 30% of the entire announced address space has a rower associated with it. So inexorable, constant growth so far, and consistent, certainly across the last 2 years, just growing, which, considering the actual address span is still growing, albeit slowly, is a good achievement. What about V6? 50,000 routes covered with a rower, but a whole lot more address space. Up over 40%, getting into 45% of address space in V6 is now covered by a rower. It's actually more coverage in V6 as a percentage term in terms of routed addresses than there is in V4. So again, consistent and steady. Now, this is where it's happening. And you have to admit, in some ways, in terms of maps of the internet, it's odd that you find the Middle East, Mongolia, Oman, Yemen, Nepal, Bhutan, Malaysia, you're testing my geography here, Ecuador, Peru, and South America leading the charge. And the US, Canada, Brazil, China, all of Africa, not. And so rowers are actually in odd places. So the production side, not where you'd think necessarily. And it's not in the areas where the internet is mature, been there forever, 30 years, we know what we're doing. It's actually in an entirely different set of spaces that traditionally we've called the developing countries in many parts of the world, except Africa. And so around the Middle East, and as I said, bits of Asia, but not all, there's a certain amount of development. And where we've normally found very high adoption technologies, like Sweden, like Finland, the answer is, so-so. So odd. So that's production, an odd map, but we're getting there. Consumption is somewhat different. Firstly, how many members did you have in MANRS now, Warwick? It was getting into the hundreds or so, as I recall from your presentation. This is the number of folk who every day, by unique IP address, ask for RPKI data from my local publication point. Now, every client has to look at every publication point every day. And so if you run your own publication point, you get to see everybody every day because they have to come to you to see if everything's changed. So I just took the logs of who comes to visit my publication point every day and count the number of unique visitors every day. And so what you see is a steady, constant growth in the number of folk who are performing RPKI local cache maintenance. Now, certainly across this year, it's been steadier than in previous years. The big growth was actually through 2020 and a step growth at the start of this year, somewhere in April, where it jumped by almost 400 unique visitors, but then steadied off a little bit. But we're up above 3,000. Now, if every autonomous system was doing this, the total visitor count would be 70,000. So in terms of the proportion of sort of active folk doing routing, this is less than 5%. So it's, we've got a long way to go if that's our objective. But maybe that's not the real objective here. It does show that it's growing. Now, the big answer. After all this work, what proportion of users will be unable to get to a place that's invalid? And the answer since June 2019 hasn't really changed much. Between 15 and 20% of users are covered by filtering, and the other 80 to 85% will be able to get to places that route origination validation says are a lie. Those peaks at the end of 2020, at the start of this year, that's me. The measurement system is unduly complicated. And I don't want to go into details here, we haven't got time, but we tried to make the system a little bigger and a little more robust at the start of this year and eventually bedded it down. And so oddly enough, now we've actually got more measurement points around the network, and that 15% I'm pretty confident in is a decent number. That's not a big number, and it's not growing. And that's unexpected because every other metric in RPKI is actually growing, but this has been constant. So why? Well, firstly, most of the uptake has been in what we call the traditional tier 2s. It's not the tier 1s, that's actually a small subset that do filter dropping, and it's certainly not the stub edges, but it's, I suppose, the traditional mid-level networks. In the Australian context, if any of you are familiar with it, I mean, Telstra's doing it, and that's great, but that's almost an anomaly. It's sort of down to the next tier in most other economies that are actually doing this form of route origination filtering. The transit networks seem to view this with a certain amount of, oh, I'm not sure, and they seem to be in no particular hurry. The other thing is that actually doing this filtering is more complex than you think, because BGP is a very cunning protocol. And even if you block and do filtering on, let's say, your major transits, if there's still a path left where these invalid routes can squeeze into your network, you're done. You have to seal everything, and you have to apply the filtering to every point where you learn routing information, because there's enough diversity in the inter-AS topology in the internet that if you just filter out your major paths, you're not filtering out anything, because once you filter those out, the invalids will leak in through other paths. So when you do this, you need to be sure you do it everywhere across your entire AS. And that, I think, also is part of the issue here. Am I going to tell you where I'm measuring from? No. You have to assume these invalids could come from anywhere, and that's the point. Because in reality, that's where they're going to come from, everywhere. So here's the next map, and I'm going to flip back a few slides when I get there. This is who's doing filtering. Now, don't forget, who's making ROAs? Middle East, South America, not much Africa. Who's doing route invalid filtering? Whoa, Africa. Huh? Norway, Sweden, not Mongolia. So the folk who are doing ROAs, and lots of them, aren't necessarily doing filtering. And the folk who are doing filtering aren't necessarily doing ROAs. But that was 2020. And there's been a lot of growth since then. Has the picture changed? October. Telstra turned it on. Yay, Telstra. And Colombia turned it on a bit. Yay, Colombia. And something bad happened in Southern Africa, in Namibia, I think, or Angola, somewhere there. June 2021. Did the picture change much? Apart from a relative change, a bit of American work, but let's go right up to the current day. October, a couple of days ago, America's looking a little bit more in terms of route filtering. Australia's looking good. Africa's changed again. Transits. As we got better at measuring this, transits made a picture. And Sweden, really good at filtering, really bad at producing rowers. Now, you're saying, well, is it my measurement system? Am I not measuring the right thing? So one way to test this out is I found a few points where I know what happened. I have ground truth. And Telstra was kind enough to tell me that in the last few weeks of July in 2020, they turned on route filtering in AS1221. What my data show, they turned on route filtering in the last couple of weeks in AS1221, pretty much across their entire network. So when you do it, this system does see it. So I'm relatively confident in what the data is telling me. And what it's telling me is that if there are operators listening today to this talk, I think I could say that most of you are looking at turning on automatic route orientation validation filtering, in other words, what we call drop-in valids, with some degree of skepticism. So while you're happy to produce rowers, they only make sense if you filter, but no one's really interested in filtering. Turning on drop-in valid is a much, much slower uptake. Here's a good example, it's just Mongolia. Why? Because the example is so stark. By mid-last year, mid-2020, 95% of all the routes originating in Mongolia had a valid rower. And this is in IPv4, but V6, I'm sure. Yeah, they do V6. Much the same story. So lots and lots and lots of rowers. Do they filter? Well, only a quarter. So the major ISPs in Mongolia, I've got a list there, you can do them yourself. But of the, I don't know, I'll say 6 big ones, and that's the list there, the big ones, 2 are doing it, 98% in both cases. The other 4 are not. They're all doing rowers, so they can't complain it's ignorance, not ignorance, but it's a deliberate decision. And it strikes me as bizarre. Why do the rowers if you're not going to do the filtering? It seems to be only half the job. So I'm going to leave you with some questions you might want to think about. Does everybody need to do route invalid dropping? If you're a stub network, if all your transits do it, you don't need to. Because if you're only learning routes from your transit, if they're dropping, you don't need to drop. And you can apply that again and again. If you think about it, there's this sort of question that's topology related. What's the minimal set of transit networks such that if all those transits did filtering, and there aren't that many transits, 20 in the tier 1 and top tier 2s, if all of them did it, the whole issue of the impact of route hijacking through Origin AS, that whole impact would be massively minimized. And the marginal benefits of a stub doing it, once that happens, is close to 0. So it's kind of interesting that everyone doesn't have to do this, but it'd be really good if transits did, because that would relieve the pressure for everyone else. And we know which of the transits that matter. That's easy to actually measure out of the internet. That's the first question. Second question, and Telstra unfortunately got caught with this, but I think they've now cleaned up their act. Because you can do the filtering on both what you learn and what you announce, ingress and egress. So should you only filter what you tell everyone else? I'm like, that's a good point. And so maybe if you are announcing routes, you should do route origination validation on what you're announcing to make sure that your own system isn't going into the bad place through some kind of error in your config, i.e. Facebook, or some other mishap in routing. And maybe every AS should do that, at least minimally, filter the egress. So what's more important? Protecting others from your mishaps or protecting yourself from the mishaps of others? Interesting question. In some ways, no one likes their dirty washing spread all over the internet. And announcing your mistakes to the world, Facebook, does give you an awfully bad reputation very, very quickly. So maybe you should. And the other thing is not much of the world protects themselves from your errors. This whole partial adoption of route invalid dropping sort of says you really should filter your egress, more importantly even than your ingress at the moment. Third question. At the moment, a prefix says, I give permission to these ASs to announce me. But unlike the routing registries, an AS can't do anything. What if an AS set a signed attestation that said, a bit like the routing registry, this is the sets of prefixes, whether they've got rowers or not, that I intend to announce. And so if I saw a route incoming, I can actually check whether there's a rower or not, whether that AS had actually claimed that it was originating that route in the first place, which actually closes the loop on some of this internet route registry issue of why the route registries and the RPKI system subtly differ. Next question. Quite frankly, we've got to protect the path, because if you don't protect the path, this is not the complete job. BGPsec, as far as I'm concerned, that it is a personal opinion, is dead, 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 dead. Lying on the back, legs in the air, howling at the moon, dead. Ain't never going to get deployed. It's just too damn difficult. However, I really do like, and we're going to talk about it in a few minutes, so I'm going to very quickly close off. We're going to talk about our ASPA. If there's anything that's going to save our bacon with AS path protection, it's ASPA. We should all be doing it. I think it's really important. So some meta questions. When we talk about routing security, are we trying to make BGP behave, or are we trying to protect our users? If we're trying to protect BGP from operational errors, it's a never-ending task. Every single day, we discover new ways to stuff up our configurations. Thank you, Facebook. Thank you, Fastly. Thank you, Akamai. Thank you, everyone else. And so we can't have systems that do that level of protection. But if this is a user protection mechanism, then that's really where we should be concerning, that stub networks should generate rowers for its own routes, but transit should do a huge amount of the heavy lifting to protect invalid routes from being propagated. Is it more important for internet exchanges and transits to perform drop invalids than stubs? And I would answer, yes. Those are the points that will make the biggest difference. So I'm out of time. ASPA is worth listening to, big advert. If you want to see more about my opinions, there's a URL there. I will keep it on the screen for the next, 3 seconds, and I'll hand the slide pack off to the ISAC folk anyway. Thank you very much, and I will hand it back. Thank you.
Thank you very much for that, Geoff. That was quite interesting, and as usual, it leaves a lot of questions in people's minds of what they should be doing, which is good, because there's no point in doing it if you're not challenging the status quo. So thank you very much for that. Up next, we have a panel session, which Andrei is going to be leading. I'll hand it over to Andrei.
Yeah, thank you. Thank you, Warwick, and hello, everyone. So we have this panel. Thank you, Geoff, for setting the context. I hoped you would say that route origin and validation is a done deal and we can just focus on the future. But still, I think we need to discuss other things that need to be done in routing security, because we all know that route origin validation is not enough. So let me introduce our panelists, and Geoff Huston is being joined by 2 other experts. Max Stucchi, he is my colleague at the Internet Society, and he works as technical advisor for European region for MANRS, IXP, and community networks. And another panelist is Alexander Azimov, who works at Yandex, and he is a well-known expert in routing security, active contributor in the IETF. He is an author of an RFC and a couple of drafts, and one of them we will be discussing today. So I would ask you to, first we will start with 2 presentations by Alexander and Max, followed up by some moderator discussion, and hopefully we'll have some questions for Q&A. So if you have a question, please post this in the chat and we'll try to collect them and address them at the end of this panel. Without further ado, let me give the floor to Alexander with his presentation about ASPA. Alexander, the floor is yours.
Thank you. Thank you, Andrei. Now it's time to for screen sharing. Okay. Hope you can see it.
Yes, we can.
Great. So once again, hey everybody, my name is Alexander Azimov. I'm working for Yandex, where I'm focusing on network monitoring, routing security, and transport architecture. And today I'm going to take you to a tour with a new RPKI object, ASP. And before jumping to the subject, let's briefly discuss why do we need another RPKI object. Okay, so the biggest reason is, of course, route leaks. That's a result of violation of peering policy. Our measurement shows that route leak can lead to 50% of packet loss. So it's a very high number, and not every TCP connection will survive. In the case of if it is redirected into such anomaly. At the moment, we have only an unstable solution based on ISets, and it has its own problems. So it degrades with time, and for example, if you would like to use it for the routes coming from provider, there will be just nothing. And one may also be anxious about malicious activity that may also happen with BGP. The good thing is that ASP can address both issues. So, yes, ASP stands for Autonomous System Provider Authorization, a new RPKI object with next structure. Customer autonomous system signs a set of its providers. And since it may have different connectivity in IPv4 and in IPv6, we also have a field for address family. Here we have a great difference from ISET. So in ISET, we have a provider who adds its customers to its list. And to the real story, they never remove it. In ASP, the situation is reversed. Customer finally is responsible for its peering policy and can add and remove providers according to its needs. The first building block of ASP verification procedure is a pairwise check. The formal procedure can remind you route origin validation. So we are retrieving all available ASP records for a selected autonomous system number. We are creating a union, which is called candidate providers. If it is empty, the outcome is unknown. If it is not empty and there is an overlap with second autonomous system number, it's valid. Otherwise, it is invalid. So it's simple and clear. So during next slides, I will provide a step-by-step description on how verification procedure is applied. And there will be some wonderful drawings. But to make life easier, let's stick on this slide for a few seconds. So if you see one circle on top of another circle, it means that the circle on the bottom is customer of the circle on top of the top. And if you see two circles on the same level, it means that they are literal peers. And arrows, it's very important. They show direction of the check, not the route advertisement. So on this slide, we will discuss the procedure that should be applied on the routes that are received from customers. There is a wonderful note about routes that are received from customers. They may consist of only customer to provider pair. So remember the procedure that we have just taken a look. It was checking that the pair is correct, that the pair is signed. So that's how we are using it. On the left side, we have a valid route where 1, 2 is a correct pair, 2, 3 is a correct pair, and we can say that the whole IS path is okay. On the right side, we have a route leak where autonomous system number 3 is leaking prefixes that are received from 2 to 4. But with ASPA, we know that autonomous system 2 haven't authorized 3 to be its provider. And that's how we are able to detect a route leak. So that's all we need for the scenario of for routes that are received from customers. Second part, what about routes received from peers? And nothing really changes. If we are receiving prefixes from routes, its IS path should consist again only of customer to provider pairs. So it has zero difference from procedure that we is applying for routes from customers. And now a bit more complicated scenario: routes that are coming from providers. In case of routes that are coming from providers, we have 2 segments. First segment is a upstream segment that we discussed in case of peers and customers. And also we have a downstream segment. And the good thing that we can both verify with ASPA. So let's take a look on the scenario on the left side. First, we have an upstream segment. We have valid pairs 1, 2, 2, 3, 3, 4. And after that, we have lateral pairs 4 and 5. And the verification procedure will return invalid. But this time, it is not about marking route as a route leak. It's marking the end of upstream segment. And after that, it should be followed by a downstream segment of provider to customer, and so on. So we can again verify it with ASPA. So we will be checking 7, 6, 6, 5. And they are valid, and everything is fine. On the right side, the situation is different. Once again, we have an upstream segment, which is correct. So we are reaching autonomous system 5. We know that 4 and 5 marks the end of upstream segment. And now we need to verify the downstream path, but in the reverse order. We will check 6, 5. Okay, it's good, it's valid. But after that, 7, 6 will return invalid. And that shows that the route is incorrect. It's a route leak, and we are able to detect it from the while receiving it from provider. So, ASPA, how it can be used? As I described, it can be used to detect route leaks from all kind of directions. You will be able to detect leaks coming from customers, peers, and very important for some networks, providers. ASPA combined with ROA can also fight malicious activity in BGP. And there is another maybe surprising note. It already works. So how it may be working without any real ASPA objects? It was first done by the NTT team, who suggested using a technology which was called peering lock. It was using well-known default-free networks and regular expressions in filtering. So it was capable to detect some leaks. The problem is, of course, that it's poorly scales. And of course, it's hard to maintain this data up to date. We also decided that we will not wait for ASPA to become globally deployed, and decided that we will try to use it at Yandex, but in a slightly different way. We applied ASP like algos to our monitoring tool. And also we used BMP as a source for collecting routes. So it is capable, because it's real, it's working, to detect route leaks from the remote originators. But more important, it is capable to also detect routes that are leaks for our own address space. So let me show how. So in this picture, we have a wonderful situation where a route is propagated according to our neighbor's routing policy, and everything is fine. Nobody is leaking our prefixes. If somebody poorly maintains its routing policy, it may result in a route leak. And still, it's not a problem until the route leak becomes propagated. And if it is, it starts to be received by, for example, your peers or your providers, and it becomes more preferable, that's when the problem starts. And the moment route leak or hijack, it doesn't really matter, starts propagating, you need to detect it, and detect it fast. But in this situation, there is a very interesting thing that, as you see, the leaker, the source of the problem is Auton System 5. And it was sending prefixes to Auton System 2. But Auton System 2, as it accepts the leaked route as a best path, will send back this leaked route to the origination. And that's where the network monitoring happens. Because with BMP, we will be able to retrieve these leaked prefix, even if our own number is in the path. Because with BMP, you are able to get routes before any kind of filtering is applied. And it really works. Here is an example where one of our peers leaked prefix to its upstream provider, and after that we were receiving it back from this upstream provider and from a couple of its peers, and were able to detect the anomaly and fix it, working of course with our peer who was source of the problem. One may wonder how many ASP records we were using to get this kind of detection. It was only 18 records. So it's not that big. It's only covers some well-known default-free networks. So it also covers our own autonomous systems and a couple of important for us tier 2 networks. Only 18 ASP records were needed to detect all kinds of leaks that are happening to our network for a couple of years at least. So I hope for now you realized that ASP is deployable, and even the earliest adopters may experience benefit from using this technology. To make it real inside your own network, you need to start working with your favorite vendors today. You also should ask your REIR for plans on support for ASP. And still, there is an open window for to contribute with ASP documents at IETF. I hope they will be ready for working group last call until the end of the year, but still there is work with needs and some small comments, and that should be addressed before it. So that's all from me. I will be glad to get your questions, and feel free to contact me if you have if you want to any more deep insights into this technology.
Alexander, thank you. We'll defer the questions till the end of this panel. And as Alexander said, there is an internet draft, so please participate and provide your comments. And there is another draft in the IETF, which is looking at the problem from a slightly different angle. And let me give the floor to Max Stucchi with the presentation about Ascones. Max, the floor is yours.
Thank you, Andrei. And as you mentioned, we are looking at the similar set of problems, but from a different angle. We look at the customer cone of an ISP, of a transit provider, and we do it in a similar way to ASPA, to ASPA. And the goal is to create feature parity between the IRRs and RPKI, and to go global and independent from the IRR. Because, as you know, as Geoff mentioned, as Alexander mentioned, we have an issue. Sometimes people build an AS set and then that stays there with its entries, and they don't get cleaned up. So the last draft we submitted focused on dealing with that, and I'll focus on that in a moment. The features are that with AS cones, you can have granularity of declarations differently from AS sets, which look only include just the customers of an ISP, of an ASN. Here we can build more granular declarations for different upstreams. For example, to one upstream, you could announce a certain AS cone. To another upstream, you could announce a different AS cone. And the idea is to have a simple validation process, but also the idea we started with was that stub networks wouldn't need to do anything. So this was a way to shift the work to the transit providers, but then we'll see that there is actually a minimal set of things that stub networks should be doing. So the idea is that we have a policy object, something that declares to this upstream, to, in this case, AS3333, I would announce default, what I have in my default rules, or to other ASNs, I would announce a specific cone or another specific AS cone. And then we have the AS cone object itself, which is basically a list of ASNs or AS cones. They don't need to have a unique name globally, because the name of the AS cone is prepended with the AS of the ASN that they belong to, and then there's the specific name. So it must be unique just per ASN. So this gives you space to do whatever you want. But then how do you find all these policies? Basically, it's similarly to what if you've ever used BGPQ3 or BGPQ4, same exact concept. Someone has created ROAs. You take the AS cone, you look into the ASNs, and you match them with the ROAs that contain that as an origin. And so you walk all the AS cones and the ASNs in your list, and then you get all the ASNs, and then you pick all the ROAs where the ASN is listed as an originator. But here is the security model that we've tried to look at. This is to avoid having issues with stale records, as Alexander mentioned, to make sure that when someone is added to an AS cone, that is meant to be. So if I want to add an AS cone to another AS cone, this requires an acknowledgement. So the idea is that if I try to add my transit to my AS cone, the transit would get a notification, and then they would say, no, this is not good. So other networks would be able to see that that was not acknowledged. The entry would still be there, but not acknowledged. And then when I add an ASN to an for the Ascones, the Ascone would not be added without acknowledgement. But for the ASNs, I can add them, and then the acknowledgement is optional. This means that I can have different ways of filtering. So I could build prefix filters with a loose system where I just get anything that is in an Ascone, or I could make it opportunistic. These are just names that we made up. You can get any ASN and any Ascone. For the ASNs, only consider those that have acknowledged. So they validated, where the field is set to 1. They said, yes, I want to be in that Ascone. You can go a bit stricter and say, I get all the Ascone, but I remove any subtrees, any part of that Ascone where any one single entry is not validated. Or you could go even stricter. I want everything to be validated there, to have acknowledged that they want to be in the Ascone. This means that I could set as a transit, as a network, I could decide what I want to do with the data I get from these Ascones. And then there is also a process on how to remove an entry from it. I can force my transit to remove my former transit. Maybe I don't want to be a customer anymore, to remove my entry. And the idea is that ASN wouldn't be able to resign to change anything in the Ascone as long as they haven't removed myself. So there would be a lock that says, you remove that ASN asked to be removed from your Ascone, and then until then, you wouldn't be able to update anything else. So this is the model that we came up with to add a bit of security to Ascones. We're trying to come up with a model that would work and would keep the system clean. The material is all there on GitHub, and discussion is welcome in GROW, ITF working group. We should be publishing a new draft soon. There hasn't been one in a while because work has been delayed. But then if you have any question or comments, we'll be here. Me, Melchior was not available today to present, and also Job, although this is his old email address. So I am finished with my presentation. I tried to be quick because we were a bit late on time, but I'm happy to answer any questions during the panel.
Thank you, Max. That was useful. Let's start some discussion. I think we looked at different facets of routing security, and routing system is quite complex. It's simple and complex at the same time. So we all understand there is no one single solution. The question to panelists I would like to ask is, as a community, what do you think should be our priority? What are the sort of building blocks we should aim at as a first priority items as a network operators community? Geoff, would you like to take this one?
Yes, thanks, Andrei. I think our priority is, I still would like to understand why the drop in valid rate is so incredibly low. You know, the message is through, they're signing rowers, but they're not dropping invalids. That's the first thing I'd like to see. Secondly, you know, this whole ASPA thing is actually much bigger than routing leaks. It's a concept we talked about a long time ago called path plausibility. Because if I tell who my neighbors are, if you try and lie an AS path and I'm included in the lie, you have to include my provider in the lie too. And so oddly enough, the incremental benefits are actually really quite good. It starts to protect the path in bits and pieces. And everyone that adds their ASPAs into this attestation set derives a benefit for themselves. It's much harder to lie about them. So it's more than just leaks. It's actually starting to protect the path. So the two things, please do route origination filtering, drop invalids. There's nothing wrong with doing that. And secondly, give ASPA a spin, kick the tires and see how you like it. Because I actually think that's where the benefit lies immediately. Thanks.
Thank you, Geoff. Someone else? Alexander, maybe you can, because ASPA was mentioned, of course.
Yeah, I hope that ASPA after this meeting and during the next year will be getting momentum. I agree with Geoff that ASPA is not only about routing. It, of course, was designed to be part of bigger picture of routing security, to fill the gaps in the unprotected ICE path without changing the protocol of BGP itself, without requiring your neighbor to support any kind of new technology. You can protect yourself without asking anybody to update the software, to buy new routers, and so on, so on, so on. It's easy, and that's why it is deployable. But speaking about what is important, still, we are living in a real world where ASPA will not be part of routing in the next couple of months at least. I hope it will be becoming part of a routing in a year or two, but still we are here. And I will advocate that still sign your roles. It's a great progress that the number of signed roles is growing. It's great because it's partially, at least partially, but protects your ingress traffic. But also, it's okay to start trying to apply filters. I know that everybody is concerned what will happen next and what can happen to the routing policy and so on. But even if you will try to apply it on your peers first, because we did it at Yandex. First, we applied it to our peers. Second, we applied it at the transits. It's a safe model to verify that everything goes fine. And if it is not, you will have time to fix it, work with your vendor, and so on. Because, for example, we faced a very nasty bug in one of our vendor software in terms of RPKI. But the security, routing security, will be joined as a community success or joint failure. If you are not doing it, routing security, you are part of joint failure.
Thank you. A clear message. Max, what's your take on this?
Oh, I think I would just follow what Geoff and Alexander said. I think while I proposed Ascones a little bit earlier than ASPA has gotten more traction and is going ahead. And I think getting that implemented would be the first step. And then I think while we have that, Ascones could also follow. And then we would have a complete picture of looking both directions in where traffic should be going, where announcements should be going. And we could also apply more stricter path validation in that point, because we could look at it in both directions. Do they match? Yes, no. And then apply even more guided choices to how we do routing.
Right, because at the end of the day, we're talking about a toolkit, right? Not just one silver bullet. Well, talking about this toolkit, I mean, if you look at the routing ecosystem, there are different entities, right, that play a different role. I think, Geoff, you alluded to that in your presentation. So from your perspective, who would be the sort of the main players that make the biggest impact? Is it like edge networks or the transit providers, tier ones? Geoff, maybe you can start.
Well, the biggest routing incidents we have are ones that affect continents, ones that affect literally thousands of networks. They're the ones that have dragged our name through the collective mud. And the reason why these things propagate so quickly and easily is actually because we run a relatively flat routing system where the tier ones, the transits, and there are only, as I said, a handful that actually do full intercontinental transit. And there are still only a couple of thousand that do even tier 1, tier 2, and low tier 3 transit. If they did route origination validation drop invalid, bad routes in terms of origination simply would not happen. And if they applied some basic elements of path plausibility, which might I mention is a very old concept, first invented with SOBGP back in, the year 2000. And so my congratulations to Alexander and Max for rediscovering it. But it is an old concept, and it was a good concept then. It's a good concept now. If we actually got those tier ones doing ASPA, it would be very hard to manufacture a synthetic route which would be plausible. Because once ASPAs are in place, it's very hard to invent associations in topology. So I would actually say, to stop the impact, to limit the impact, it's actually the transits that have, if you will, the most leverage. Stubs are a much lower priority in my view. Yes, stubs cause leaks, they can cause issues, but without the transits propagating those mistakes, you're shooting your own foot off, and that's your right, and please do so. But yeah, transits really need to get into the picture. And so if you want to put some MANRS focus on where you can do the most leverage, we should be actually making a hard point and naming and shaming transits, and we know who they are, that don't do route origination filtering and are complicit in actually propagating bad routing information. Inadvertently, yes, but they're still complicit. Thanks.
Thank you, Geoff. Any response to that, Alexander? Is Yandex an edge network? Would you consider Yandex an edge network, a sub network?
Yeah. I think I need to highlight that in today's world, there is a most important, I can't say most important, but the biggest volume of the traffic comes from CDNs to the end users. And I believe that if we want to secure routing system, we need to secure transit on one part and CDNs on another part. Because if CDNs with multiple peerings, multiple connections at the IXP points will not use, will not apply measures for the routing security, it will not result in a very good and predictable situation. For CDNs, they can do different things already. For example, in Yandex, we are also using what we call flat routing priority. So we have same local preference for all our peers and all our providers. They have same local preference. We have same local preference for everybody, which makes route leaks harder to get in our system. Because normally route leaks have a longer IS path and they become less preferable. But at the end of the day, routing security should, in my opinion, should be at least be present at the key points of the internet. So in today's world, it T1s, biggest T2s, IXPs, and CDN providers, or content providers. It's not only CDN.
Thank you. And luckily, in MANRS, we have different programs for different types of network operators. So if you're not the MANRS participant, please join and contribute to routing security. So I would like to remind our audience that please, if you have questions to our panelists, please put them in the chat. We'll collect them and cover in the Q&A session that follows. But let me wrap this up with sort of last question, which is maybe a rhetorical question. When do you think we can consider our job done with regards to routing security? And maybe Max, maybe you can start with.
Yeah, I get to be the first one on the hardest question. So this requires a much longer, much bigger discussion. We could consider that done once we have built a system where we don't see any hijacks happening, or we don't see any other leaks happening. This will take a long time, and I'm not even sure it will be feasible, because as we've seen in many other cases, it's not just by building systems like ASPA, by adding then Ascones, or maybe in some years BGP-SEC, that we will, and I said maybe, it's not, I see Geoff saying no, but I say maybe, you never know. It's not just by adding these mechanisms that we will protect everything. There are also other layers. And I also like to say that people always find incredible ways to break systems. And so we will always be chasing all these issues one way or another. We can put more safety nets in place. ASPA, Ascones, something else that will come up soon, ROV. But then I guess we will sort of never be done with this, and it will, and we will always come up with something new.
Yeah, I think we need to look at this as a positive message, and we all know that security is not a state; it's a process, right? Geoff, you said no. I mean, maybe you can respond.
Well, you know, let's look about this. And if you take a protocol-centric viewpoint, don't forget we can't protect withdrawals no matter how hard you try. So there's an important part of BGP which is unprotectable, but that's actually not the key to this. If you take a user-centric view of what we're trying to do, we're trying to make sure that when you send your packet with an IP destination address, it goes to that address. Now that's blind faith. And one of the weirdest parts of this faith is actually faith in the routing system, that the route you get corresponds to the forwarding path your packet's going to make. And in all this work about protecting the routing protocol, what no one's yet figured out, and I suspect no one will in my lifetime, and I intend to live a few years yet, and it's much harder to actually validate that the information in the routing system accurately corresponds to the future switching decisions that your routers are going to make. And it's only when you get to that degree of assurance can you actually say, when I put a destination IP address in a packet, I am confident that the packet will go to that place and not somewhere else that's pretending to be that place. Now, correcting routing stops the first level of egregious errors, mishaps, and all kinds of slip-ups. But a truly well-resourced, determined attacker that can take over your routers can subvert forwarding without necessarily subverting routing. But if the true issue is users' packets and protecting where they get to, that's the bit you're actually really worried about. Actually trying to make sure in the end that addressed packets end up where they're meant to be going and not elsewhere. That's going to take us a lot of effort. Should we wait for perfection? God, no. Should we wait for universal adoption? Of course not. Should we actually wait for BGP-SEC to ever get good? We're all going to be dead, okay? There are solutions like ROV and ASPA that work with partial adoption, that give incremental benefits for incremental deployment. And that's the bit that I think works for absolutely everyone. The quick win that actually we're winning really well on is ROAs. And as you see, we're up to 30% and growing, easy peasy. The next win is route origination and validation and drop invalids, and we're struggling. That number, instead of 15% of users, should be kicking 50%. You know, quite frankly, if Australia can do it, and I wouldn't say we're the cleverest people on the planet, far from it. If we can do, anyone can. It's not that hard, but there seems to be an awful lot of reluctance. But if you do it, the benefits are to your users. It's your users that are actually seeing the incremental benefit. And that's the bit I think that actually we need to look at as you will, a priority in MANRS. And then we should move on to AS-PATH. And as I said, I think we've talked that to death. But, you know, should we wait for BGP-SEC? Never.
Thank you, Geoff. And yeah, let me ask Alexander to share his views.
Yes, today I'm working for a company that is working with it depends on the happiness of its users. So I will put that the happiness of the users is the best metric, at least for such a big company like Yandex. And in case of routing security, happiness depends on if the path is disrupted by any kind of routing anomaly or not. So my measure of success is that we are not using, as a company, leaked or hijacked prefixes. They are not accepted, and we are not sending traffic in these directions. And our prefixes are not leaked and or hijacked somewhere, and so our ingress traffic is not affected. I believe that the needs of Yandex are not that different from the needs of any other company. If it is a content provider or providing, for example, an internet connection.
Thank you. And unfortunately, we are running out of time, so I think we have only time for one question from the audience. I see there are a few of them. From Kevin, what would you consider to be the easiest wins? I think, Geoff, you probably addressed this question to a large extent.
I think I did, yeah.
And there is a question from Ben. Geoff, can you describe the changes you've seen in the raw filtering in South Africa in some more detail? The data you've seen seems to be odd. Okay, maybe you can take this one.
In some detail. We use an invalid target as an anycast address from a large-scale CDN these days. So you're going to go to the bad place if sort of there's any path to any of those CDN points of presence left on the globe. And what that means is that it's a really tight test. You've got to drop all possible paths to an invalid route in order for me to treat you as doing filtering. And quite frankly, what's going on is folk aren't dropping everything. The follow-up question, which TAL covers the invalid? The 5 RIR TALs. I'm not doing AS0 tests. This is a conventional route, conventionally routed. It just happens to be with a rower with the wrong AS number. So, you know, it's invalid using standard TALs.
Recording stopped.
Wow, that was quick. So the real issue is cover every path. Don't do a partial
Recording
path,
in
Ben.
progress.
That's the secret. You've got to cover the lot. And that's the issue, I think, with Southern Africa. They've done a half an implementation of ROV dropping. And in ROV dropping and routing, half is nothing, unfortunately. You got to put a finger in every hole. So that's what's going on there.
Geoff, may I just jump in?
And I think, folks, I apologize. We have very little time. So I think you know where to find people that were on the panel. So please continue if you have questions and discussion there. Thank you very much. I'd like to thank our panelists for excellent presentations and great discussion. Thank you very much. I hope that was interesting and useful for everyone. Thank you.
Thanks. Thanks, Andrei. Cheers.
And I would just like to echo as well, thank you very much to everybody who has participated. Our final agenda item of the day is the new MANRS Observatory data, which Andrei is going to talk through for about 5 minutes. And then we'll follow up from there. Over to you, Andrei.
Yes, hopefully you can see my slides. Let me just put it in full screen. Yeah, I would like to talk about the observatory data and what we are trying to do with that. So when we launched the observatory a few years ago, I think the main objective of this, for this tool, for the MANRS participants, was to inform you about your degree of commitment, which is aimed to improve reputation and transparency of the whole effort, make it more credible, and also facilitate continuous improvement and correction. So for those, who haven't visited the observatory, and I'm sure there are none of those here on this call, but this is the landing page where you get when you enter the observatory, and at the bottom you have this donut charts, which show MANRS readiness scores as related to a particular filter that you installed. And in most cases for you, that would be your network or your networks. So those scores, they're based on a measurement framework that we set up, and we measure using public data sets. We use passive measurements that allow us to actually calculate the scores for all networks on the internet, not only actively cooperating, but that brings some caveats with the data. And one of the caveats I would like to sort of, focus on, which is related to filtering. This is one of the very important actions. And to be honest, it's running too fast. With the data we're using, there are too many false positives, some obscure algorithms and different vantage points that would like to improve the quality of this data. So what we did recently is we connected yet another source, data source, to the data from a team in Qrator, working on what they call BGP Observatory, or another name is GRIP. We added this data and to make the quality higher. So yeah, you can see this in this top right corner. There is this checkbox that allows you to select or switch between GRIP and BGP stream data sources for your routing incidents data. Now, I would like to draw your attention to another thing. So when you go to detailed reports, and I appreciate those reports only available for MANRS participants. General public doesn't have access to this part of the observatory, but most of you are MANRS participants. So when you go here, you can see this table. This is a table of actual MANRS readiness scores for networks participating in MANRS. Now, there is a difference if you go to the website, and on the website, you see tick marks. And well, there is corresponding thing that we do the checks, we use observatory to monitor the data, but not everyone knows that. And I was faced with a question whether this is self-declaration, which is not supported by any measurements, but also some of those tick marks, they're not 100% compliance. They actually indicate some lack of due diligence and some systematic negligence, I would say, for some of the networks. So I think we discussed this a couple of times, and there is intention to move from those tick marks to actually numbers to show the public what are the actual MANRS readiness scores are sort of beyond those ticks. But for this, we need to improve quality of data. We need to be 100%, well, maybe not 100, but 90% confident that if we detect an incident, that's a real incident. So we need to bring false positive to an acceptable level, acceptable for you to be able to publicly state the scores. So what we did with the recent release, which happened in summer and was announced on the MANRS mailing list, is we introduced the feedback function. So when you go to your detailed report, you can now go and click on this little icon with the feedback and provide feedback on a particular incident. So you can say, yes, it's an incident, or this is not an incident, or part of the data is incorrect. And this feedback loop will be recorded in our database and will help us to improve quality of data and tune up the filters that we are using to reduce the rate of false positives to this acceptable level. So I think all our intention, and I hope you support me in that, to move from ticks to numbers, to really indicate your MANRS readiness scores that will improve further transparency and credibility of MANRS, and that will facilitate continuous improvement and correction. So please help us, and thank you. We'll follow up with a more detailed email communication on the mailing list. We would suggest maybe a reminder that people should go and sort of provide feedback on the incidents, because we haven't got a lot of feedback since we introduced this feature in the summer. We really hope on your support. And if you have any quick reactions now, I would like to hear them. If not, we'll communicate further on the mailing list. Thank you.
How do you rank quality versus quantity in a number system?
Well, what we really want to do, there are two things that come along with this data, there's a certain rate of false negatives. I think all the systems, they do not catch all routing incidents, but that is not a problem for conformance measurements, right? What is really a problem for conformance measurement is higher rate of false positives when we, the systems or the data we're using label a particular routing change as an incident while it's a legitimate change, right? Without knowing intent, and both BGP stream and GRIP, they work on observing routing changes without knowing the intent and peculiarities of relationships between the networks. So this is not surprising that false positives are there. But what we really need feedback from network operators telling us, no, you're wrong, this is a legitimate change, or yes, this is an incident. So when we detect those cases where the system indicates an incident while it was a legitimate change, that allows developers of those systems go back and look at their filters and improve the quality, reduce the number of false positives.
Questions for Andrei? In fact, are there any more questions for Geoff, Andrei, Max, or Alexander on the panel session from before? Because we can allow one more question or two. If not, we'll say thank you very much. And thank you for attending this MANRS session. We really appreciate it. And as everyone has mentioned, please feel free to reach out on the MANRS mailing list and let us know of anything that you thoughts in regards to the topics we've talked about today. And we really appreciate your time and interest in trying to improve the routing security. And with that, I also would like to just follow up with, yes, I'd like to see a t-shirt from Geoff about BGP-SEC being dead. And I'll join in the queue for people lining up for those. Thanks very much, everybody. Have a great evening.
Thanks, Warwick.
Recording stopped.
So I don't know what happened with the recording halfway through that. Just seemed to.
Yeah, we just, stop, start, and then off it went again.
I don't know whether we seem to be having some gremlins really in all of our systems, like the calendar system that randomly cancelled the meeting last week. I have no idea what happened there. It was nothing to do with me, even though it all came out in my name, so it was all a bit embarrassing.
I was just going to mention that the ISOC Live is still going on Facebook.
Jolly. Jolly, can hear me? You there? Okay, maybe Kevin, maybe let's close this meeting.
Okay. Sorry, there was just a question in the chat. Yeah, we'll make a summary of some of the main points from this, and that will go out. But we can certainly share on. I'll just type my email address in. So anybody has any questions, if further questions or queries, just send them to me. But I think we're good.
Alrighty.
Thanks, Warwick. Thanks, everyone.
Let's end it and see you later this evening.
Yeah, see you then.